presented homework 2. First, I would like to thank Professor and TA for giving me such a great opportunity, and all of you guys coming. Had a busy season, like final thing. I'll go over with the contents first. I will explain briefly about the game, and then I will explain defining states and rewards. Defining states and rewards will be the two main topics of today's presentation. Then I will continue on with the policy function, learning parameters, and my conclusion. And at the end, we will have a Q&A session. So let's start with the game. There is information for the game, and I think top two information was easy and it was given, but I think many students might have missed the information on the bottom. The stable is the stable indicates that the catchable exposition of items for each basket location. So for example, for basket located at 6, the basket will be catching the exposition of 8, 9, and 10. This will be used later on with the rewards. So first thing is that the defining states, and my first approach was to connect every information on the screen. By connecting every information, I mean connecting basket location and every item's X position, Y position, whether it is a coin or a time. So for this picture, the state will be 4911, 551, 660, and 781. This is very long state, and the number of possible states for this first approach is about 31 billion states. 31 billion states is not a very good idea because a lot of states means that probability of one state appearing multiple times in episodes will decrease. That means that it requires more training and more time. After training my computer for 48 hours, I realized that the first approach has no hope, so I moved on to the next approach. The second approach was by labeling the item according to the basket's location. So if the item was in the basket range, I labeled it 1, and if the basket range was, if the item was left to the range, I labeled it 2, and the item right to the range, I labeled it 3. From lowest to highest, I connected every label, and for this picture, the state will be 231. For the second approach, the number of possible states will be 120 states. It is a good improvement from 31 billion states to only 120 states. This second approach was not bad, but sometimes there are occasions with low score or ending too soon. I searched for the problem and I figured out that the problem was the time. Because the basket couldn't distinguish between the time and the coin, if it fails to catch the time at the beginning phase of the game would end too soon. So I added more rules. The new rule is that if a time appears, we ignore any other coin and only focus on time. So it works the same as the last approach. So if the time counter is in range, the state will be 7. And if the time counter is left to range, it will be 8. And if it is right to range, the state will be 9. So adding 3 more states to the previous 120 will end up with 123 states. And this is all about my defining states, and it pretty worked well. So let's go on to the defining rewards. The default reward that TA gave was the difference of score plus difference of time. This is quite straightforward, but what if time item exists? If time item exists, the state is only 7, 8, or 9. So if the score difference is counted as a reward, the basket will be confused because the basket's only objective is to get the time at the moment. So even though the basket acted correctly to obtain the time item, score is worsened because it has to give up on catching coins. Worsened score gives signal to the program to recognize it as a bad behavior. So I gave some tweak on state 7, 8, and 9 to only count the time difference as a reward. So this is my reward. If time item does not exist, the reward will be the score difference plus time difference. And if time item exists, the reward will be time difference only. But there was one more complication. If we look at the table, we can see that the basket position 7 already covers basket location 8. Because 7 can have 9, 10, 11, and 8 can catch 10 and 11. So it will be very silly for the basket to locate at 8. So I gave a minus reverse when the basket is in 8. This is all about defining reverse, and let's go on to the Poisson function. I haven't changed much about the TAs given Poisson function, and I used the epsilon greedy Poisson function. And the epsilon greedy Poisson function takes two parameters, the epsilon and the learning rate. Any epsilon 0.1 to 0.001 and learning rate 0.1 to 0.01 worked well to me. There was actually no difference between the variance of epsilon and learning rate to my method. Now it's the conclusion. The conclusion is all about trade-offs. If the number of states is too big, then it will take more time. But I haven't tried, but I think it will get more accurate. So more states means accuracy and more time. And if I had unlimited time and maybe a supercomputer, I could have better accuracy. So that's all of my